Hello everybody, this is Dr. A. N. Balmurugan, Associate Professor, Department of Electronics and Communication Engineering, St. Joseph's College of Engineering. I welcome you all for this session to discuss about this ISO OSI layers. Initially, we should know what is ISO. The ISO stands for International Standard Organization. Then next we will discuss about this OSI. OSI stands for Open System Interconnection. Again I will repeat, the OSI stands for Open System Interconnection. That means what it refers to this OSI in the sense, any two autonomous systems can communicate without knowing the underlying architecture is known as OSI. I will repeat again, any two autonomous systems can communicate without knowing their underlying architecture is called as the OSI, Open System Interconnection. Before we enter into the topic, we must know what is the meaning of autonomous systems. The autonomous system in the sense, it can have their own set of protocols, own set of topologies, own set of routing algorithms and own set of policies, service level agreement and transmission policies. So that is called as the autonomous system. Any two autonomous systems can communicate without knowing their underlying architecture is possible only because of the OSI layer. This OSI layer contains 7 layers. This OSI layer contains 7 layers. Each layer has its own specific responsibilities. Now we will see that what are the 7 layers in OSI. The lowermost layer is called as the physical layer. The lowermost layer is called as the physical layer. The second layer is called as the data link layer. The second layer is the data link layer. The third one is called as the network layer. The third layer is network layer. Physical, data link, network. The fourth layer is transport layer. The fourth layer is transport layer. Then next layer is session. Then followed by presentation. The uppermost layer is called as the application layer. The uppermost layer is called as the application layer. Always when we have a question that a list of OSI layers in the sense, we have to start from the physical layer. Physical, data link, network, transport, session, presentation and application. We could follow the order from the physical to application. Now we are going to discuss about this. Each layers specific responsibilities. First I will start with the physical layer. In physical layer, the information in the physical layer is in the form of stream of bits or chain of bits. Information in the physical layer is the form of stream of bits. The meaning of stream of bits is nothing but zeros, ones, 0, 0, 1, 0, 0 in the similar way. That it is called as a stream of bits. The information in the physical layer in the form of stream of bits. What are the other specific responsibilities of the physical layers are? The first one is physical media characteristics and interface. Physical media characteristics and interface. Characteristics and interface. Now we will see what is physical media characteristics and interface. You have media. This media can be classified as two types, wired and wireless. Wired media and wireless media. You can classify accordingly the two types, wired media and wireless media. See, depends the application, you have to prefer any one of the wired media or it is applicable for the wireless. It purely depends upon the application what we are using. The wired media, we have 3 types of mediums are available. The one is twisted pair cable, another one is coaxial cable, the third one fiber optic cable. These 3 are the wired mediums we are using. Wired medias are classified as 3 types: twisted pair cable, coaxial cable, fiber optic cable. What is the primary difference between these 3 cables in the sense? The frequency supported by the cable and the data rate supported by the cable. For example, if you are seeing the twisted pair cable, it will support from few hertz to few kilohertz range of frequencies alone. Few hertz to few kilohertz range of frequencies alone. In the similar manner, if you are going up to the coaxial cable, it will support from few kilohertz to few megahertz range of frequencies. It will support only few kilohertz to few megahertz range of frequencies. When you are coming up to the optical fiber cable, the light is the medium, so it can support up to few megahertz to few gigahertz range of frequencies it can support. In the similar way, if you are seeing the data rates supported by the cable, you could see the twisted pair cable is support only kilobits per second, some bits per seconds to kilobits per seconds. In the coaxial cable, it will support some kilobits per seconds to some megabits per seconds. But the fiber optic cable can support in a wide range. It's from megabits per seconds to some gigabits per seconds. Megabits per seconds to gigabits per seconds. So that is the primary difference between the three different mediums available. Depending on the application type, because for example I am saying my data rates will be lies between kilobits to megabits in the sense the suitable cable is the coaxial cable. If suppose my application lies in the megabits to gigabits in the sense, I have to select the optical fiber cable as my medium. So depending my application, I am preferring a media from the wired type. If it is a wireless in the sense, we simply say this is a air as the medium. But we can classify the range by using the frequency. For example, I just want to say one thing, that Bluetooth is a remote. So Bluetooth is the wireless, TV remote is the wireless, cordless telephone is the wireless, mobile phone is the wireless, television broadcast is the wireless. I ordered 5 items in the wireless. The first one is Bluetooth, the second one is TV remote, the third one is the cordless telephone, the fourth one is mobile communication, the fifth one is television broadcast. But what is these are all coming under the category of wireless. But the primary difference is the range. You can observe that the Bluetooth, the TV remote is applicable only in a very short range. The cordless telephone, you can take the headset to the next floor itself. You can, it is possible. But when you are coming to mobile communication, since you can roam around anywhere, you can speak without the wire. The last category, television broadcast in the sense, in your earth you can transmit in any one side, you can receive the information in any other sides of the globe. That is possible. The range is extended. Why? How the range is extended in the sense, it's only depending on the frequency of operation. Even though I am saying this is a wireless, there will be different categories of wireless bands are available. These applications lies in a different bands. According to the band, the operating ranges differs. So that is the physical media characteristics and interface. So you have to select according to your application any one of the medium, either it is a wired or wireless. Wired in the sense what type of media you are going to use, wireless in the sense which type of frequency you are going to use as operating frequency. Okay, next is the media. The next category is the same in the interface. That means the twisted pair cable and coaxial cable is coming under the category of the electromagnetic signals. The signal which is passing through, we call this generally electrical signal. Informally we can call it as electromagnetic signal. The information will pass through this. Nowadays what we are using the systems, it delivers the electrical signal, so it can be easily passing through this cable. But when you are coming to the optical cable, you need to convert your electrical signal into optical. Electrical to optical. In the another side of your destination, you have to convert this optical signal to electrical signal. Now my question is, I need to select one interface which is used to convert the electrical to optical, then vice versa, in the another side optical to electrical. We have studied, we have the device, in the electronic devices, it is called as the LED and laser, which are the devices used to convert the electrical signal into a optical one. If you are giving the electrical signal, the light illuminates from the LED and the optical. So finally the information will be converted into a optical signal. But it have a primary difference between these two. One is the chromatic, another one is the non-chromatic source in the sense. In the other side you can use this OE conversion, optical to electrical, we can use the photodiode and phototransistors. When the light illuminates, the illumination falls on this device. According to the illumination, the resistance value will be changed. According to that, the output voltage will be varying. So you can convert the optical to electrical, electrical to optical possibility. That is called as the interface. That is called as the interface. So the primary responsibility of the physical layer is choose the physical media, characteristics and interface according to the application. So next is representation of bits. Next is representation of bits. Representation in the sense, we have only a digital signal. You can see representation of bits. So what we are actually using is digital signal. It will be represented as logic 0 and 1. Logic 0 and logic 1. In the electrical form, we can easily encode this information or represent this information. That means plus volt will be represented by logic 1. In sometimes 0 volt will be for logic 0, or sometimes we can use negative voltage for the logic 0. That depends polar and bipolar encoding types. But in the case of optical, in the sense, how we represent the logic 1 and logic 0 in the sense, in fiber optic, because light is the medium, so how we represent the logic 1 and logic 0 in the sense, high illumination in the sense it's a logic 1, high illumination in the sense it's a logic 1, low illumination in the sense it's logic 0. Again I am saying clearly the high illumination is logic 1 and then low illumination is logic 0. No illumination in the sense no signal is transferred. That is the second responsibility of the physical layer, representation of bits. Third one is data rate. Data rate is a transfer rate. The another name for the data rate is transfer rate. That means number of bits per second. Number of bits per second. So the transfer rate or data rate will decide the entire network performance. If your data rate or the transfer rate is good, your network performance will be good. So it has to be decided by a number of factors. The one is what type of medium you are using. Then second, what type of topology you are following. The physical topology is also most important. Then next responsibility is line configuration. Line configuration in the sense it can be classified as two types, point to point and point to multi-point. Point to point and point to multi-point. Point to point and point to multi-point. Point to point in the sense, single sender, single receiver. Point to multi-point in the sense, single sender, multiple receiver. Point to point is single sender, single receiver. Point to multi-point in the sense, single sender, multiple receiver. This is the another responsibility of the data link layer. Now you have to consolidate all these things of the physical layer again. The physical layer is the lowermost layer of the OSI model. The physical layer is the lowermost layer of the OSI model. And the information in the physical layer is a stream of bits or chain of bits. Stream of bits or chain of bits. The specific responsibilities of the physical layer is physical media, characteristics and interface. How to choose the media and interface for this type of application. Second is representation of bits. How your logic 0 and logic 1 will be represented in the electrical form and the optical form. Then data rate, that means the transfer rate. Then line configuration, point to point and point to multi-point. That's all about the physical layer. Again I will already I told you that every layer has its own specific responsibilities. Now we'll move on to the second layer. It is called as the data link layer. Now we move to the data link layer. It's the second layer of the OSI model. Okay. Data link layer. In the data link layer, the information in the form of frames. Information in the form of frames. In your physical layer, the information in the form of chain of bits. Now it will be converted into frames. We will see what is framing. The first specific responsibility is framing. Second one is physical addressing. Physical addressing. Third one, flow control. Third one, flow control. Fourth one, error control. These are the specific responsibilities of the data link layer. These are the specific responsibilities of the data link layer. The first one is called as the framing. Second one is called as the physical addressing. Third one is flow control. Fourth one is error control. First we will see from the framing. What is the meaning of the process of framing in the sense? These stream of bits which is in the physical layer will be converted into data manageable units called frames. Framing in the sense converting the stream of bits into data manageable units. Data manageable units. That means I am converting this raw bits into a package. We have two types of framing. One is fixed size framing, another one is variable size framing. Fixed size framing in the sense the number of bits in every frame will be equal. The number of bits in every frame will be equal. But in the case of variable size framing, that the number of bits present in the frame will be differ from frame to frame. The number of bits in the frame will be differed from frame to frame. That is called as the variable size framing. We have two types of framing, fixed size framing and variable size framing. The next is physical addressing. Adding a MAC address to the frame is called as the physical addressing. Adding a MAC address to the frame is called as the physical addressing. You know what is MAC? MAC stands for Media Access Control. MAC stands for Media Access Control. The another name for the physical addresses is called as the Ethernet address. In every computer you have an Ethernet card. The Ethernet address is referred to as physical addressing. Later, when I am coming to the third layer, I will introduce the one more term. It is called as the logical addressing. That is completely differ from the physical layer. So now you can understand, then you can perhaps grasp the concept here. The physical addressing in the sense adding of MAC address to the frames is called as a physical addressing. MAC stands for Media Access Control. Media Access Control. We have different types of media access control methodologies in the Ethernet. IEEE 802.3, IEEE 802.4, IEEE 802.5. You know the series. IEEE 802 is the Ethernet series. IEEE 802.3 is a simple Ethernet. IEEE 802.4 is called as the token bus. IEEE 802.5 is called as the token ring. These are the different types of media access technology. So depends that the MAC address will be changed for the frames. So adding of MAC address to the frame is called as the physical addressing. When I am coming to the flow control, it is most important. The flow control, how I am defining this flow control in the sense, the absorption rate of the receiver. Be clear about this. If the absorption rate of the receiver is lesser than the generation rate of the sender. So what will obviously happen? The data loss will happen. The absorption rate of the receiver is lesser than the production or generation rate of the sender, in the sense that the information will going to loss. To reduce the loss, to avoid the loss, we incorporate the mechanism that it is called as a flow control. That means we inform the sender to slow down your process. to quench the rate is called as the flow control. To slow down the process or quench this generation or production rate to match according with the receiver is called as the flow control scheme. What we exactly doing in the sense, once we receive the acknowledgement from the receiver, the sender can go for the next frame. So obviously what it is the meaning, the previous frame has been successfully received, so they are expecting the next frame, so we can go for the another frame. So that is the technique we follow in the flow control scheme. The next one is error control schemes. We are transferring a huge amount of information. That means, for example, I am having a 10,000 bits of information. I am saying bits, or else bytes you will refer it later. You are using the word bits. I am having a 10,000 bits of information. I am converting into a 10 packets, so 10 frames. I am converting into 10 frames. So each frame will contain 1000 bits. Each frame will contain 1000 bits. So if the receiver receives this information, sometimes due to the link problem, the error may occur. What I am referring the word error here in the sense, any logic 1 will be interpreted to 0 or any logic 0 will be converted to 1. That will be called as the error. If it is only one time it is appear in the sense a single bit error, 2 times is a 2-bit error, 3 times is a 3-bit error, it is goes long in the sense we call this as a multi-bit error. But in our data communication systems, we are following only error detection technique at the receiver. We are using the error detection technique at the receiver to know whether any error present in the data or not. If we find some error is present in the sense, we will not try to correct the errors. We simply discard, the sender will simply discard the frame and it will inform the sender to resend the frame again. Or you must note down here, the error in error control schemes, we are trying to find any error in the data or not. We are not involving ourselves to correct the error. Once error is present, we know some error control techniques we are following. For example, CRC, it is used to detect the error in the received information. So if error is present in the sense, we simply discard the information and we will inform to the receiver that resend the information. We will not give any interest to detect correct the errors. So these are the specific responsibilities of the data link layer. Again, one more time, I consolidated everything. Information, the data link layer in the form of frames. The 4 specific responsibilities are framing, physical addressing, flow control and error controls. What is framing in the sense? The stream of bits in the physical layer will be converted into a data manageable unit called frames. Then physical addressing in the sense, adding MAC address to the frames is called as the physical addressing. Flow control in the sense, to slow down the process of the, to quench the generation rate of the receiver when the absorption rate of the receiver is very lesser than compared to the sender. The last is error control. We are trying to locate if there is any error in the data or not. If any error is present, we simply discard the information. Rather, we try to correct the errors. These are the responsibilities of the data link layer. Now we will move on to the, now we have seen physical and data link. Now we will move on to the network layer. The network layer is the third layer. The network layer is the third layer. Network layer is the third layer. Information in this layer is called as the IP packets, as simply called as the packets. The first layer, the information in the form of stream of bits. In the second layer, the information in the form of frames. In the third layer, information in the form of packets. The 2 specific responsibilities of the network layers are routing and logical addressing. Routing and logical addressing. These two are the specific responsibilities of the network layer. And moreover, the network layer is responsible for sending a packet from a single packet from source to destination. A single packet from source to destination. How we are going to send this? In the sense, the network is composed of various routers, there are n number of routers. From each source to each destination pair, you have n number of possible routes are available. But we need to find the shortest path between the source to destination. That is the important responsibility of the routing. Routing is nothing but forwarding of data packets. Routing is nothing but forwarding of data packets. Forwarding of data packets between the source to destination. Forwarding of data packet between the source to destination. But when you are forwarding the data packet from source to destination, then you have to find out the shortest path between the source to destination. You have n number of possible paths are available between the source to destination, but you have to find out the shortest path. That is the important responsibility. Shortest path. What I am referring the shortest path here is, I have to take any one quality of service matrix. I have to take any one quality of service matrix. You have n number of quality of service matrix are there. Quality of service matrix in the sense hop count, link cost, delay, bandwidth. These are some samples of the quality of service matrix. You have to prefer any one quality of service matrix. Then you have to find out the minimal quality of service values to reach your destination. For example, I am taking as a hop count as my quality of service matrix in the sense, I need to take a minimal hop count I reach to destination. That is link cost. Every link having some cost value. So if I preferred, this is my quality of service matrix in the sense, I have to find out the shortest path, which means the minimal link cost between the source to destination. You have a routing algorithms are available. For example, the Bellman-Ford algorithm, which is used to compute the minimal hop count between the source to destination pair. Digit-star algorithm, which is used to find minimal link cost between the source to destination pair in the way. So you have to follow the quality of service matrix and find the shortest path between the source to destination. You have to follow the path, then reach your destination. Okay, these are the quality of service matrix. Then second important responsibilities are the logical addressing. Logical addressing in the sense adding IP address to the packets. You know what is IP address? IP address stands for Internet Protocol Address. IP address stands for Internet Protocol Address. We have two versions. Internet Protocol Address IPv4, IPv6. We have two versions, IPv4 and IPv6. So adding the logical addressing to the IP packets is the responsibility of the network layer. So far we discussed two addressings. The layer 2 addressing is called as the physical addressing. Layer 3 addressing is called as the logical addressing. In some simple way, for a student, I will give you some example to understand the concept of the physical addressing and the logical addressing. You have a number, it's called a roll number and register number for the candidate. The roll number, which is equivalent to the MAC address, we did not in the second layer, data link layer. I can locate the candidate inside the campus by using the roll number. From outside the environment, outside the college, I could not find anybody by using the roll number. But you have another unique number, it is called as the register number. The first four digits represents the college code. The second two digits represents the program, which year he was admitted. Next three digits represents the program code. That means we are belonging to which discipline, electronics and communication or computer science or mechanical, whatever it is. The two digits represent this. Last three digits will uniquely given for the candidates, which is equivalent to the IP address. The IP, your register number is the best example of the IP address, and your roll number is the best example of your physical address, which is we see in the second layer. So these are the network layer fundamentals and responsibilities. Again, I will consolidate these things before I am going to the transport layer. Network layer is responsible for single packet from source to destination. Then the two important responsibilities are routing and logical addressing. Routing in the sense forwarding of data packets between source to destination. The physical addressing is adding IP address to the IP packets. The rest of the things we will see in the second session. Thank you for your cooperation.